All right, so for 9.2, direction fields and Euler's method, we're going to look at direction fields together, and then I'm just going to let you guys read the rest of it so the video is not too long. You should be able to use the worked examples in WebAssign and these notes to do the second part. So for the first part, direction fields, it's possible to solve most differential equations in the sense of obtaining an explicit formula for the solution. But instead we can learn a lot about like the graphs through these, so slopes at all different times. That's what the slope field is. Okay, you can watch those two YouTube videos if you'd like. Okay, so suppose we were asked to sketch the graph of the solution of this problem. We don't know the formula, so how can we possibly sketch a graph? Let's think about what the differential equation means. So differential equation just means that it is the solution curve, and it's all the different slopes at certain values. Okay, so the way that we're going to do it is we're going to show the slopes at all different values with these little dashes. That's what a slope field would look like. And from that, you should be able to kind of see maybe what the graph looks like. Okay. Okay, so we're going to do this one. So sketch the direction field for the differential equation, and then use that to sketch the solution curve that passes through the origin. So we've got our equation, and we're basically just going to pick random xy points that we want to find the slope for, plug it into that equation down there, and that's going to get me the slope at each of those points. So I'm going to start with maybe -2, 0. So y prime at -2, 0 is -2 squared plus 0 squared minus 1. That's going to equal 3. So the next one is going to be -1. So y prime equals -1 squared plus 0 squared minus 1. That's going to be slope of 0. The next one, we're going to do 0, 0. So y prime equals 0 squared plus 0 squared minus 1. So our slope is -1. And then they just kind of go on like that. So basically we've got all these points, and at each of those points, the slope at each of those points is at the bottom. So at -2, 0, it's right there, our slope is 3. So it's going to be kind of a steep slope, and it's going to go like that. At -1, 0, it's right there, our slope is 0. So it's going to be just a horizontal line. At 0, 0, our slope is -1, so it's just going to be like that. And remember, these are just sketches. So at 1, 0, our slope is 0, so it's going to be a horizontal again. At 2, 0, our slope is +3. This will be steep. At -2, 1, our slope is 4, so it's going to be slightly steeper than our 3 slope. At -1, 1, our slope is 1. At 0, 1, our slope is 0. At 1, 1, our slope is 1. And at 2, 1, our slope is 4. Okay, so that's just like a couple of them, and they just keep going, and that's kind of how you would sketch it, but that's what it would look like with all of them drawn. So we had this one drawn, we had this one drawn, we had all of these ones. Sorry, not those. Okay, so we had all those ones drawn, and then we could fill in the rest. So basically what you need to be able to do is know like what these little tick marks mean, kind of how to read this graph, that at each instantaneous point, that's the slope of that point, that's the slope at that point. Okay, and then if we continue to draw to the solution of the curve so it moves kind of parallel to nearby segments, we've got this kind of curve here. Okay, and remember that when your slope is 0, that's when your derivative crosses the x-axis. So, and you have a max or a min. So our slope was 0 like here, so that means that that was the max and that was the x value of the min. So, all right, and that was kind of it for that. So, look at the AP College Board videos that I've also linked in to this assignment and complete the 9.2 problems on your web assignment.